In this video, I'll be going over how to balance redox reactions in both acidic and basic conditions. So the first thing you always want to do when you start balancing one of these reactions, you need to identify which element is being oxidized and which element is being reduced. One common thing I see get confused is people will say that a compound is oxidized or a product is reduced. That's not necessarily true. Particular elements are oxidized and reduced. So let's go ahead and figure out which element is being oxidized and which one is being reduced in this reaction. So if you went through and calculated the oxidation number for the manganese over here, you would get +7. And if you did it for the one over here, you would get +4. So we can see here that the oxidation number is getting more negative as you go across here. It's getting less positive. That means we must be gaining electrons if you go from a +7 to a +4. So that means this is our reduction. And then if you look at the iodine goes from a -1 oxidation number to a 0. We're getting more positive as we go over here. It must mean we're losing electrons. Oxidation. So if you're still a little confused or a little shaky on being able to identify these reduction and oxidation reactions, go ahead and review this process here. But now let's actually get into balancing this in acidic condition first. So first off, we'll balance it in acidic conditions. So what I always like to do when I start balancing one of these reactions is I like to just split my paper down the middle. I just draw a straight line down the middle. And what I do is I balance each half reaction first, then I combine the two. Because you're going to have a reduction reaction and you're going to have an oxidation reaction. I just treat them separately, balance them separately, and then combine them at the end and cancel out like terms on both sides. I tend to find that much easier than trying to balance it. It's just like this mega reaction. So over here I'm going to do the reduction reaction, and over here I'm going to do the oxidation reaction. What I do is I balance the reduction first, then I balance the oxidation, then I combine them. So here's my reduction reaction. And the first thing you always want to balance is the non-oxygen, non-hydrogen elements. So we don't have any hydrogen here. We do have oxygen, but we do also have this manganese. And that's what we need to balance first. Well, luckily in this one, the manganese is already balanced because we have one here and one here. So we don't have to worry about that. Like I said, we don't have any hydrogens. So now we want to worry about balancing the oxygens. And to balance oxygens, you add water molecules. And the deal is you add enough water molecules to balance the number of oxygens that you need. So on this side, I have 4 oxygens. On this side, I have 2 oxygens. So that means on this right side here, I need to add 2 water molecules. Remember, there's 1 oxygen in every water molecule. So adding 2 water molecules will give me those 2 oxygens that I need to balance the number of oxygens on this side. The problem, though, is the fact that since we've added the 2 water molecules over here, we've also added 4 hydrogens because we have 2 and then H2. So 4 hydrogens have been added to this side, and we have no hydrogens on this side. So that means we need to balance the number of hydrogens. And to do that, you add H plus ions. So you just add enough H plus ions to balance the number of hydrogens. So over here, that means we're going to also add 4 H plus. And that will balance the number of hydrogens. So that's what my reaction looks like now that I've added those 2 waters and the 4 hydrogens. So all the elements are balanced now in the reaction. The problem is the charge isn't balanced. Charge balance is just as important as elemental balance. So over on this right side we have a neutral charge, which means our charge is 0. And over here we have a -1 charge, and we have 4 +1 charges. So -1 + 4, that gives us a +3 charge over here. To balance charge, you're going to add electrons to the more positive side in order to balance the charge out. your charge does not have to be neutral. Your charge just has to be equal on both sides. And we'll see that in a little bit, where we'll use electrons to balance out a negative charge. But since this side is neutral and this side is positive 3, we're going to add 3 electrons to balance out the charge for both sides. So here's our balanced half reaction down here. And so we're kind of finished with this reduction reaction for right now. Now let's take a look at our oxidation reaction and balance that. So looking up here at the oxidation reaction, we have this I- that's going to I2. So luckily we don't have any oxygens or hydrogens in here, so we don't have to worry about those. But we do need to balance the number of iodines here. So I've got 2 iodines on the right side, and I've got 1 on the left side. So to balance that, I'm just going to put a 2 right there. And that will balance the number of iodines. But now we have to worry about charge balance. Over here, we now have a -2 charge because of those 2 I-. Whereas over here, we have a neutral charge on the I2. So we have a -2 over here, neutral over here. So I'm going to add 2 electrons over here to balance the charge out. That's why I was saying the charge doesn't have to be neutral on both sides, it just has to be the same. So we have a -2 over here, and now we also have a -2 over here. So now that I've got both half reactions balanced, I need to worry about combining them into the same big reaction. But before I do that, I want to cancel out my electrons. And that's because I don't want to see any electrons in the final reaction. So you'll notice that over here on the right side of the arrow we have electrons, and over here on the left side of the arrow we have electrons. So that means if we find a common factor between these two, we can multiply them by that common factor, and ultimately we'll be able to cancel our electrons on both sides. So we have 3 electrons here and 2 electrons here. So my common factor would be 6, right? So if I multiply this one by 3 and this one by 2, that will allow me to cancel out the electrons. The key here is knowing that you need to multiply the whole reaction by that factor. So we'll multiply that one by 3, and this one will multiply by 2. So now I have 6 electrons over here and 6 electrons over here, and that allows me to cancel out the electrons. So now what you're going to do is combine the reactions based on which side of the arrow your compounds are on. So you'll combine the 6I- with everything over here on the left side of the arrow, and you'll combine the 3I- with everything on the right side of the arrow. So you'll combine them together in one big reaction. So once you combine them, you'll arrive at your final reaction if you're balanced in acidic conditions. And you know it's balanced in acidic conditions if you have these H+ left over. So unless your H+ somehow cancel out, sometimes that does happen, then you wouldn't see any, but most of the time you'll see these H+ ions in your final reaction. And that lets you know that it's balanced in acidic conditions. But let's take this one step further, and let's balance it in basic conditions. To do that, you would do all the previous steps the same way. You would still balance the equation in the same way. But when you get to this step here, you'll have to do a couple more steps to balance it in basic conditions. So to balance in basic conditions, you'll take the side that has the H+ on it, and you're going to neutralize that by adding 8 OH- ions. Remember that OH- and H+ make water when they're put together. So when you add these two things together, they'll make 8 water molecules, neutralizing it. But you have to do the same thing for the other side. So you also have to add 8 OH- ions over here. So you add 8 OH minus ions to both sides. So now, when you combine those OH minus and H plus ions, they become water, so you just get 8 water molecules out of that. And we have our 8 OH minus ions over here that we added to this side. So now the only thing we have left to do is balance the waters. So the last step in your basic condition balancing is to just balance out the waters on both sides. So you see we have 4 water molecules on the right side, and we have 8 on the left side. So what you're going to do is you're going to subtract the 4 over here to the other side. Like that. And doing that will cancel out the waters over here, and this will give you your final reaction in basic conditions. So here would be your final reaction, written out, balanced in basic conditions. So here we have our 2 possible outcomes: balanced in acidic or balanced in basic. So if you're balanced in acidic, you'll be looking for those H plus ions. And if you're balanced in basic, you'll be looking for those OH minus ions in the final reaction. And that's essentially how you balance redox reactions.